Hello, welcome back to your construction materials and testing. Okay, so this is your module 4. In this module and video, we will be discussing about wood, metals, paint, and then the ceramics, okay, which is a material used in construction, common materials used in construction. So we will be starting with this wood, okay. So the wood material, we classify that one into two types, the hardwood and the softwood. So hardwood, it is commonly or we call this one as the angiosperm, okay, and then the softwood, we call this one as the gymnosperm. So the hardwood is mostly coming from deciduous tree, okay. If we say deciduous tree, these are the trees which loses its leaves annually. The leaves are changed annually, so we have a season of this tree for spring and fall. And then this hardwood is growing slowly. That's why the grains are dense compared to the softwoods. Okay, so you can read about this in your copy. So we have here your evergreens. So if you say evergreens tend to be less dense than deciduous tree and therefore easier to cut, while most hardwood tend to be more dense and therefore sturdier. In practical terms, this denseness is also means that the wood will split if you will pound a nail into it. Okay, thus you need to drill screw or bolts to fasten hardwood together, but structural lumber is soft and light, accepts nails easily without splitting, and thus great for general construction. So that explains the advantage and disadvantage of your softwood and hardwood. Okay, so if you say softwood, it is of course literal. The strength of that compared to the hardwood is low. Okay, so if we are after the strength, then we should be using the hardwood. But again, the disadvantage of that, as discussed in this paragraph here, is that the hardwood tends to split if we are going to drill or if we are going to pound a nail. Okay, if you are going to pound a nail on that hardwood, that will tend to split because of its composition. But if you are going to do that in a softwood, that will accept. So if you are going to compare, okay, for example, a yakal and a pine tree, okay, it is easier for us to pound a nail on a pine tree than in yakal, because in yakal, maybe what will fail, or you cannot pound a nail because maybe the nail will deform, or simply if the nail will penetrate, the yakal wood might split. So the connection to be done or to be used for those hardwood types of wood are what we call as these screw and bolts. So we need to drill so that it will not exert an effort to split that grains of your hardwood. And then the advantage of that is the other advantage of your softwood, and of course the other advantage of softwood from your hardwood is, of course, it is lightweight. And again, most of the time we are using this type of material, wood, on the trusses, or it could be on the divisions of our rooms. So those materials or those purposes should be requiring a lightweight material. So we are using their light wood type of wood. Okay. So this is an example of a cross section of a wood. We have here what we call as the pith. We have there the medullary rays, the growth rings, or we call that one annual rings, the sapwood, the heartwood, the dead bark, live bark, and then the cambium layer. So if we say annual ring or growth ring, that's why we call this one annual ring, because actually each year of the growth of the tree will be additional one growth ring or annual ring. Okay, so actually this will define the years or the age of the tree. So the pith actually is where the growth ring will start to form, and then that will grow outwards. Okay, so it is wrong for my idea before, or the most idea before, that your cambium layer is the what we call this one start of the growth of the tree. No, actually the cambium layer is only just a layer which will replace the bark once the bark is destroyed. Okay, let's say that is damaged through what we call this one, external factors, maybe natural phenomenon. The bark will be destroyed and that is still fresh. So we have here the cambium layer to replace that one, but that is not where the growth is starting. It is starting from the pith. It will form an annual ring there and that will grow outwards. Okay, so that means that since that is the characteristic of the growth of the tree, therefore the strength of these layers is also proportional as we go outwards, directly proportional from the distance from your pith. So as we go outwards, the strength will become stronger compared to the inner growth rings. Okay, so these are the cross section of our wood. So in using this one, so if they are going to sow, okay, they are going to sow a certain dimension of a lumber out from this wood, we are actually getting that on this part, okay, on the what we call this one, earlier annual rings, not on the middle. Seldom that we are using the middle. They are actually sewing this one or dividing this cross section, and they will try to remove the pith, since that pith is actually what we call as the juvenile. Okay, it's a juvenile that is still very weak. Okay, so iniiwasan natin yan. So most of the time we are getting the outer part or the outer growth rings if we are trying to create or to cut a lumber. Okay, so these are just the definitions of those parts. We have here what we call as the green wood. It is a newly cut wood, which is actually still fresh. There are types of wood, of course. We have what we call as this green wood. If you will try to harvest a wood which is not yet fully grown or that is not on the season of drying, and then once that will reach its let's say common lifespan, it will now start to what we call this one, dry on its own. So that is the fully grown tree. But if you are harvesting still a fresh one, that is what we call a green wood. And then these are the types of sewing. Okay, so if you are going to cut the cross section directly from, or that will serve as a cord. Okay, if I will cut the, let's say that's a circle cross section, you're going to cut that one straight from the very top to the other side of the circle, then that is a plain sew. Okay, so most of the time we are using this on these wide lumbers. Okay, for example is a, let's say a 1 inch by 1 inch by 12 inch size. So that will be using a plain saw, since that will try to cut your cross section directly from the top to bottom. But if you are, let's say if you need smaller sizes, then we can actually do this quarter saw. So we will try to divide your cross section into 4, and then that is where we will be fitting the sizes that we need. Okay, and that depends, of course, that depends on the division, or that also depends on the type of the tree. So natural characteristics affecting mechanical properties. Okay, so the reason why we are not using commonly this type of material, the wood, as a main structural member is that the property of wood is not that predictable. Okay, because of this because of these characteristics that is affecting the strength or the mechanical properties of this wood. Okay, so these are just some, but there are a lot actually. So one there is the nuts. Okay, we cannot predict the strength because we do not know if there will be a nut within the length that we are trying to cut. Or we have here the other types: reaction woods, juvenile wood, the peat, okay, the pitch pocket, the bird peak, or these are just actually the, what we call this one, factors. Okay, these are what we call the factors that is affecting your properties of this wood. Okay, so if you say knot, that portion is that portion of a branch that has become incorporated on the bole of a tree. So of course, if you try to cut that one, for example, you are after a 2x3, and then suddenly we will now be cutting within this part of the knot, then this knot will actually weakens your member, which is a 2x3. Okay, maybe that will be on the half or on the edge part, then that will still be reducing the strength, okay, of the size that we are after. So knot is the common natural characteristic that is affecting your property of the wood. Reaction wood, okay, this is also, as you can see on the figures here, the distribution of the annual ring is not uniform. That is due to leaning. Okay, maybe the tree is grown while that is leaning, okay, towards a certain direction. So you will expect that the types of this reaction wood depends on the type of the wood, of course. Okay, so this will be true to a dicots type of woods, and then this is true to conifers. So if that will lean towards this, then that will be forming what we call as the compression wood. And then if that will be this type of wood, if that will be leaning towards this direction, that tension wood will be formed. Okay, so that is the different formation of reaction woods in these different types of trees. So that will also affect. Why is it affecting the mechanical property? Because of course the density of each of these annual ring will be different due to the irregularity of the distribution. Okay, so for example, we want to calculate, to estimate the strength of a certain cross section of a lumber that is cut from this tree. Then you cannot predict that one uniformly, because of course the distribution or the strength of each of this layer is different due to these reaction woods. And then we have also the juvenile. I explained this one a while ago, wherein we call this one juvenile because this is the early age part of the tree. This is the late age or late wood. It means that this is already higher strength compared to the juvenile part. Okay, the earlier or the later or the less age annual rings of your tree. So that will also affect also the the property. While because we cannot say that if I will cut here a certain cross section of a lumber, I cannot say that the strength is uniform of the cross section. That's why that depends on the type of trees. Okay, if that should be a plain zone or that should be a quarter zone. So we have here these are defects. Okay, we call this one as defects of trees. So one is the pitch pocket. Okay, it is this well-defined opening that contains free resin. Okay, so we can find here a resin. Okay, that is the resin, which will actually affect the uniformity of the cross section. Okay, we have here also bird picks, of course, that is common on an area with a lot of wood pickers. That will also affect your tree, properties of your tree. A wane, okay, this is the presence, this is irregularity of the shape. That's why if you will try to cut a certain cross section that might be ending up with a corner of a bark, we call this one wane. Okay, so seldom that's why we are using this seldom, since again most of these will occur on a tree that are irregular. So on other countries, they are using this as a main. They are using this type of material, the wood, as main structural member. They will be using this as a beam or a column, but not on the high-rise construction, because of course the properties are not that predictable compared to concrete and steel. Okay, considering this, a lot of factors affecting, okay, these natural characteristics and together with the defects, that will of course make your property not that predictable. And if you will try, of course, to consider designing, we should have a material that has a predictable property so that we can incorporate that one in the design. Okay, that's why in the big construction, maybe we will be using this as part of division or even trusses. Okay, we are only using woods as part of trusses in small constructions. Let's say that is just a house, or that is just a what we call this one, bungalow type. Okay, but in high-rise building, we are not using this wood. Okay, as a member, or what we call this one, as a structural member. We have also what we call as a check, another, or not yet, we are not yet done with the warping. Okay, so warping is also another defect which is actually prone on a lumber with a cross section or with a thickness which is very very thin compared to the length of the cross section. Let's say this one. Okay, if that is almost a square, then maybe this warp is not that prone. But if that is very very thin compared to the length, for example, that is in this size, that is free to warping. If you say warping, that is distortion. If you observe this piling of trees or piling of lumbers in construction, they are supporting all through the length of this lumber all throughout. Okay, or maybe within 1/3 points or 1/4 points to support your member from warping. Okay, or maybe every other month or every other week they are trying to rearrange or they will try to flip, okay, the piling of your lumbers. So again, for the cross section of this lumber not to have distortion or undergone warping. And then we have also here what we call as the check. Okay, that is a cracking on the grain parallel, or on the cross section parallel to the grains. So that is prone on other types, and this is actually common on green woods or on the woods which is actually not fully matured. We have here also what we call as the shake. That is almost the same as the pith, but the pith is happening more on the juvenile part. Okay, we have here the shake, separation of grain between the growth rings, often extending along the board face, sometimes below its surface. So these are the types of the shake: star shake, ring shake, heart shake. Okay, we have also this split. So that is a total longitudinal separation of fiber which tends to the opposite face of the lumber. Okay, from the other side through or across the pith. That is a split. So we have also here what we call as the stain. That is the discoloration that penetrates the wood fiber, can be on any color other than the natural color of the wood. Okay, it is a discoloration. It could be blue or brown. Spalt. Okay, and any form of discoloration caused by the fungi. Dry rot. So we have here fungus breaks down wood fibers and then renders the wood weak and brittle. We have also, this is also common, the wormholes. So these are just some of the natural characteristics and defects of a wood that will make your properties not that predictable. Okay. So again, these are the reason why we are not using this type of material in actual construction as a main structural members. Okay, due to its unpredictable property. So these are the three classes of preservatives which are commonly used for pressure treatment of pine timber. Okay, this is for pine timbers. Waterborne, solvent-borne, oil-borne. So waterborne chemical solutions comprise a mixture of water-soluble compounds of copper and other chemicals in the treatment of rural fence posts. Other chemicals can be included in the formulation to prevent glowing and smoldering of the wood. Examples of these are copper, chrome, arsenic, okay, CCA, alkaline copper quaternary, ACQ, and then your copper azole. Okay, and then we have here your solvent-borne. Solvent-based chemicals such as LOSP are solutions of fungicides, insecticides, and some cases water repellent chemicals. Okay. White spirit is the solvent commonly used for LOSP. If you say LOSP, that is the light organic solvent preservatives. Oil-borne, this is an oil-based, okay, treatment. Oil-borne preservatives such as creosote and pigment emulsified creosote are a complex mixture of chemicals obtained from the distillation of coal tar. Being a liquid, it is normally used without addition of solvent. Fuel oil, however, is sometimes added to facilitate the treatment of railway sleepers. So these are your example, your creosote, pigment emulsified creosote. Okay, so those are just the treatments. These are the liquid treatments for us to sometimes, what we call this one, get rid of these other types of defects, especially your stains and then the insect related defects, just like wormholes and then others, just like the bird beaks. And of course, to preserve the wood from aging, we have what we call as the visual sorting criteria. Okay, visual grading is the original method of stress grading. It is based on the premise that mechanical properties of lumber differ from mechanical properties of clean wood because many growth characteristics affect the property, and these characteristics can be seen and judged by eye. Growth characteristics are used to sort lumber into stress grades. The typical visual sorting criteria discussed here are nuts, the slope of grain, check, split, shake, density, decay, hardwood, softwood, pitch, pockets, and weight. So what do we mean by visual sorting criteria? So this is just a method or a way of sorting your lumber with respect to strength. Of course, we cannot test. Let's say I will try to cut a member on that certain cross section, and then I will test that one, and then the result of that will be true to all of the cross section or to all of the type of the tree. No, we cannot do that, since again there are a lot of factors affecting this, and again that is stated here: the defects and of course the natural characteristics of the wood that will affect the strength. So if ever, even if you tested one of that member or one of that lumber from that group, then that will not represent the strength of all of this, since again these woods of different ages and different sizes and different properties or different characteristics has different strength. So therefore, we are not actually doing much of testing in woods. Maybe only to we will be doing testing on a certain type of wood just to represent a specific scenario. Let's say that is fully grown with a well-distributed grains, and that is given a certain year, okay, and then that will only to represent for an approximate estimate of the strength of that certain type of wood. But that is not true on all the, of course, ages of that type of wood. So again, instead of doing most of the time the testing, unlike in steel and concrete, once you will test a part of that batch of concrete or a batch of steel, then that might represent the strength of the batch. But that is not true. So we are doing what we call as the visual sorting. So this is just, of course, to separate or to sort your members or your woods with respect to the properties, mechanical properties. I mean, with respect to the characteristics that can be found on that certain member. So maybe if you consider a check or a shake in density, then you can sort that out on a group to separate that from the batch or from the two type. Okay, so visual sorting. We are not doing it as usually in testing. We are going to sort that one maybe based on your, what we call this one, observation. As the one observing, that might be having a closer strength to this one, so you are going to group that one together. So that is visual sorting based on what you observe on the defects and of course natural characteristics of that member or that lumber. Okay, so that is for wood. And then we will now be going on metals. Okay, the metals, the common type of metals that we are using on construction are classified into two, non-ferrous and ferrous metals. If we say ferrous, we are referring here to iron, okay, iron. So if we say ferrous, those are metals with iron content, and then non-ferrous, those are metals with no iron content. So actually the iron content most of the time is the one that will make our metal stronger, okay, the iron content. But before we will go there, actually I included here this table, okay. This is a table for testing of these different types of materials. Since I did not include this one on the concrete, discussion of concrete, okay, since this is also true for other types of material just like steel and together with water, okay, so I will discuss it here. So this is a standard, okay, for testing samples that will represent the batch, okay, to be used on construction. If we are talking about cement, okay, the minimum testing requirement for per 2,000, okay, that is per 2,000 bags. If you are going to use a 2,000 bags on construction, there should be one sample allotted for testing, each for 2,000 bags. So let's say you have there 5,000. So you might be needing there a 3 sample to represent the batch of 5,000 bags. Since again per 2,000, or even if that is not 2,000, less than 2,000, that should be represented by one sample. And then one sample is equivalent to 10 kilograms. So that means that just like what I've said a while ago, let's say we are representing 5,000 bags, then it says there that one sample per 2,000, so we might be needing 3 samples, which is 10 kilograms each sample. Therefore, we will be needing 30 kilograms for testing for that 5,000 bags. So that is how to use this table. So aggregate, that depends on the type of aggregate. We have the coarse and then fine. So for the minimum testing requirement of this type of material, aggregate, one sample per 1,500 cubic meter. Okay, CUM stands for cubic meter. So per 1,500 cubic meter, we need to have, okay, at least for coarse aggregate is one sample of 70 kilograms, and for fine aggregate is 50 kilograms. And then you have here your concrete. So for testing of cylinder, so if you say cylinder, that might be used to test your compression strength. Okay, so one sample per 75 cubic meter. So if you are going to pour a concrete mix which is 75 cubic meter or less, there should be one cylinder sample for that. Okay, and then one cylinder set, or one sample, if you say one sample for cylinder is one set, and if you say one set, that is composed of 3 cylinders. By the way, why is it that 3 cylinders? We are going to test these 3 cylinders, and then we are going to get the average, and then that will be the result. Okay, that's why we are having 3 cylinders in one set. Same with the beam, okay, per 75 cubic meter, or 1 day pouring. If you say 1 day pouring, even if you did not reach the 75 cubic meter in 1 day pouring, if you still did a pouring in a day, you need to represent that by one sample or one set of sample, which is 3 cylinders for beams and columns. By the way, this is a column, okay, columns or beams. Okay, so this is for beam, this is for cylinder. Okay, this is the shape of your sample. We have what we call as the cylinder concrete and then the beam concrete samples. So this is cylinder and that should be beams. Okay, 3 beams. And then for core, if you say core, that is applicable for pavements. So if you are paving a highway, we need to test that one. If that is within the standard, and this is the minimum testing requirement for that. 5 holes per kilometer or per lane. Okay, per kilometer of each lane. So it says there that once you already poured there, let's say, or you already constructed 1 kilometer of one lane, then we need to test that one with at least 5 holes. Okay, using your core testing. And then you have here your water, chemical analysis. Okay, we need to do chemical analysis. And then sediment load analysis. Okay, 500 millimeter each for this testing. Concrete hollow blocks, so 1 sample per 1,000 units. So per 1,000 hollow blocks, you need to have 3 units. That is the sample. 1 sample is 3 units. Okay, or 3 pieces of your hollow blocks. So for strength, that is 3. For moisture content, that is also 3. Reinforcement steel. So we are now on steel. 1 sample for per 10 tons. Okay, so that is per weight. So we need to test that one, and your sample is 1 meter. Okay, structural steel. Okay, if you say reinforcing steel bar, these are your reinforcing bars. And if you say structural steel or sheet, these are now the other types of structural steel, which are the maybe column or the beams, which could be in different shape. It could be in I shape, or it could be in tubes. Okay, so 1 sample for structural steel, 1 sample per 50 tons. Okay, so those are the minimum testing requirements. I just included that in this discussion, since I did not discuss that one on the concrete. So now let's proceed to your metals. So this is now on the metals. So engineering materials, we can divide that one into metals and non-metals. The non-metals could be rubber, plastic, resins, and of course the other types. It's like concrete, wood, and so on and so forth. And then we have here now the metals on the types. On the metal types, we have here the ferrous and then the non-ferrous. As I've said, that only differs because the other one has iron content and the other has none. And then those non-ferrous metals are, examples of those are copper and then alloys. Okay, if you say alloy, that is a mixture of different types of metal: aluminum, zinc, tin, lead. Okay, and for ferrous metals, this could be purely iron. Okay, pig iron, cast iron, wrought iron, and steel. Okay, all of this contains iron material. And then actually the only difference of this iron here is due to the manufacturing. Okay, is that a high temperature processed metal, or is that not? And that depends actually here. It will be discussed later on. So metal is an element or compound or alloy that is a good conductor of both electricity and heat. So metal crystal structure and specific metal properties are determined by metallic bonding force holding together the atoms of metal. So this is just to, of course, introduce ourselves with metals. And then other specified metal features: luster or shine of their surface. Okay, those are the other specific metal features. And then malleability, ductility. So these are the important malleability, the important property or features of the steel that we need in construction. And then ferrous metals, okay, contains iron, base metal, and then for non-ferrous do not contain iron. Okay, so again, this is just in the another what you call this one, breakdown of the types of these metals. So you can see here your ferrous metals, and then this is now the definition. So iron, pig iron, you can read about the difference of this type of iron. So iron, pig iron, cast iron, okay, casted iron. And then your cast iron, we have here types: the gray cast iron and then the white cast iron. You can read about that. We have here what we call as the wrought iron. Okay, and then we have here now the steel. Okay, this is the common, the steel. And then stainless. If you say stainless, by the way, what is the big difference of a ferrous and then non-ferrous metal? Of course, as I've said, that is due to the it's either this metal contains iron or not. But what is the effect of that? Okay, the iron will make it more stronger, okay, compared to all these other types of non-ferrous metal. But also, the iron will make your metal prone to rusting, okay. oxidation due to oxidation process. Of course, you discussed that one in your chemistry. And then we have here now the altered type of steel, which is what we call as the stainless, is a type of steel which is anti-corrosion or anti-rusting. Okay, that will not corrode or that will not rust. So we have here the non-ferrous metals, aluminum. So as you can see, there are pictures here for the common examples, okay, and then the common use. The steel and the stainless steel are the types of iron that are high strength compared to the other types of cast iron or iron. We have here the non-ferrous, the aluminum. Okay, this type of non-ferrous metal is a lightweight. So commonly we are using this on the roofing, okay, since these are lightweight type of metals. And of course, this is without iron, so that is prone to rusting. Copper, this is for electric conduction or conductor. Brass and bronze, okay. Seldom that we are using this, since actually the price of this due to its shiny property is a little bit expensive compared to the others, okay. And then tin, okay, so this tin is used in coating steel and alloy element in the form of foil, can be die cast, cold work, machine, and soldered, cannot be welded. Okay, so this is the type of metal commonly used on corrugated shapes, roofing. Okay, since that is easily formed on a thin sheet. Okay, or it could be on what we call this one, in the form of foil, maybe for wrapping. And then lead, nickels. Okay, so nickel is for commonly for the nails. That is also a high strength. Heat treatment of metals. So these are now the treatments. So we have here what we call as the heat treatment of metals. The controlled heating and cooling operations used to bring out the desired change in the properties of metal. Its purpose is to improve the structural and physical property of the metals. Okay, so let me just share the experience that we had in the what we call this one, field trip before. We tried to visit a mill, okay. Mill, if you say mill, that is a manufacturing of steel, structural steel, steel bars or structural steels. So when we visited this mill, we tried to observe that the raw materials are also steel, but the strength of that is not that high. And then that is to be undergone on such a process or manufacturing process for that to be in the form of the or on the strength that they are after. Since if you'll try to observe, there are this what we call as the strength of steel. We have what we call as grade 40, grade 60, and so on and so forth, and that determines the strength. But these type of material used are the same. So the only difference of that, that's why the strength are different, is on the processing or manufacturing. Okay, so to process that raw material steel, they are going to melt this metal, and then they are going to reshape that one and to alter the properties by maybe compaction and other of course significant properties for them to reach the desired strength. So the heat will actually alter the strength of the material. Okay, even if they are the same, if they undergone different processes, then they will end up with different strengths. So we have here what we call as these are the process: heating, soaking, and cooling. Okay, these are the different types of process to alter or to improve the strength of the metals. So these are the methods of marking of metals: stenciling and stamping. If you say stencil, that is to be engraved, and then stamping, that is to be what we call this one, stamp. So just like stamp, that will just be in addition to the surface, that will be protruding on the surface. If you see stencil, that will be engraved. Okay, so that is the marking of steel. And then we have here now the structural connections. It's either we are using rivets or we are using welding, and of course bolt if we are using bolt. So these are the three types of connection of structural steel. So rivets or riveting, holes are punched or drilled through the members to be connected, and the steel rivet will be inserted through the holes. So this is a common way, okay, on thin sheets of steel. If you are going to connect thin sheets, let's say we are connecting plates, this is the common process or common method of connection, the rivets, using rivets, since again we are going to drill or punch, and then there will be a steel rivet inserted, and then that will of course be finished. So that is this is commonly used on thin sheets, while welding and bolt, these are commonly used on thick members, because it is not that easy for us to punch a hole on the actual site or on site to insert a rivet on thick members of metals. Therefore, we are using what we call as welding and then the bolts. The only challenge here on the bolt is that there are common errors on manufacturing, wherein again, let's say the alignment of the holes of the, let's say that is a column and the beam, the holes that is punched on the manufacturing of the beam is not aligned to the holes punched on the column. So that is the common challenge in using bolts, since again the holes are already punched on manufacturing before they will bring the member on the site, while on the rivet they can do the punching on site, since again that is that might be a thin member of metal. Welding, okay, we have here the welding. The also challenge here in welding is the alignment, because maybe we are considering here big members. So the challenge there is for us to steady the member, to get the connection of the member while the welding is ongoing, because of course if this member is moving while we are welding, then that will affect of course the connection. So this comes with different types, of course. The rivet needs to conform with the strength of the connection. So maybe that's why your connections are being designed based on the number of bolts, number of holes, number or the thickness of the members being connected, and then that will require a certain certain strength of the rivets. The same with the bolts. So we have also grades for the bolts and rivets, and of course your welding. We have these types of welding and grades of welding also, because of course the connection is critical, especially on structural member. The connection should be strong enough for the member to use its total strength before it will fail, or of course not to fail, of course, because that is not designed to fail. But for example is if the strength of the member should be reached before the connection will be failing. So that's why it is also important for us to design the connections. We have here now what we call as the grades. Okay, so this is important. This is for reinforcing bars. Okay, this reinforcing steel bars. So if you are using PNS standard, okay, PNS is a Philippine national standard, and then ASTM, this is for American Structural Association, Steel Association. This is American Steel Association. This is for Philippine national standards. These are the classes: regular steel bar, and we have what we call as the weldable. And actually, if you say weldable, that could be welded. Okay, your steel bar can be connected through welding. Okay, your regular steel bar, this we will be using here your tie. Okay, we will be using here your ties to connect or to lap your steel bars. So the what we call this one? How do we categorize this one is based on the color coding, which is set by these standards. Okay, so this one is red grade 33, 40, 60, 75, and then grade 60. These are the grades. Okay, 230, 275, 415. So this is actually on the megapascal. That is already the grade in megapascal. In your PNS or Philippine National Standard, that is already, the strength is already stated. So 230 means that the strength of that is 230 megapascal. 415 strength is for 115 megapascal. For ASTM, that is on this type of numbering, okay, the grading is done on the numbering. Grade 30T is equivalent to 230 megapascal. So that is the meaning of that. Grade 40 is 275 megapascal. Grade 60 is 415, and so on and so forth. By the way, that is not given there because these are already high strength. So that depends on the required, on the manufacturing of this steel. Okay, and these are the color coding. If that is white, that is grade 30T. Okay, grade 33, or that is 230 megapascal. Yellow is 40, 275. Green is 60, 415. A mixture of blue and green is a grade 75. That is a high strength. Okay, it depends again on the requirement of the steel. And then weldable, the only additional color or the indication that that is a weldable, because the weldable steel could be grade 33, grade 40, grade 60, grade 75. Okay, so if that is 230, for PNS, we are denoting that one with the letter W. It means 230. That is 230 megapascal weldable. That is the meaning of your W. Or in color coding, that is a white on the other side of the bar, and in the other end there is a red color. The red stands for or represents welding or weldable. Okay, so this is for your reinforcing bars. And we have here what we call as the corrugation, okay, or deformations of the bar. By the way, if you might be observing this one and you might be asking yourself, what is the use of that corrugation or that deformations on the bar? That's why in designing, we are stating there on the general notes that we should be using deformed bars. Okay, so it means deformed bars, we should be using a bar with these deformations. And we have these types of deformation. Okay, it's either a cross deformation or a rectangular deformations. And what is the use of this deformation? That is actually to enhance, okay, the friction of the steel bar with the concrete. Because if that is a smooth surface, then the friction between the concrete and the steel is weak. Therefore, we require in design, we need to require a very long length of that bars for the strength to be totally, what to call this one, to be formed or to be reached totally. Since again, if that is a very, very, what to call this one, that is a steel bar with no deformation, it means that is a plain surface, then the connection or the bond between the concrete and the steel is weak against friction. So, before this, let's say this is the steel bar. Before the steel bar will reach the strength, that will fail through friction. Okay, so the concrete and the steel bar will separate, and then without reaching the required strength. So without using for example, we are using a grade 33, or that is a 230 megapascal. Without reaching that 230, the concrete and the steel bar will separate or will fail. So that is the disadvantage of not having a deformation on your bars. That's why they put a deformation to enhance the connection of the bond between the metal and the concrete. Okay. And then we have here now the testing of your metals. Okay, so tensile strength. This is ASTM E8, A-8, that is the designation for this tensile strength. So this is to test the tensile strength capacity of our steel. That could be any type of steel. It could be steel bar, or it could be plain, okay, corrugated or plain steel bars. Shear strength. Okay, so the testing here is of course through tension. In your shear strength, the testing there is of course through what we call this one, shearing. that is ASTM D1002-10, and then these are the other types: compressive strength, elasticity, okay, elasticity, ductility, malleability. So these are the other properties of strength that is necessary for the design of structural steel. So you can read about that. Now we can proceed to your ceramics, that is for structural steel or steel members. So we can now go to your ceramic products. So for construction, sector includes cement and cement-based material, interior and exterior tiles, sanitary wares, non-refractory bricks, and other more complex shapes such as drainage, sewer, and chimney pipes and linings. So these are where we are using your ceramic products. Okay, so we have here your tiles, bricks, sanitary ware, shingles. You can read about those. Okay, so these are the types of the materials which are under ceramic products. Okay, you can read about that. So paint, we have here also what we call as the paint. Paint is a liquid surface coating. On drying it, okay, forms a thin film on the painted surface. Paints are classified as oil paints, water paints, cement paints, bituminous paint, special paints such as fireproof paints, luminous paints, and then rubber paints. That depends on the object the paint is protecting. Okay, so we have different types of paints, and that depends on the purpose of the paint. So we have here your functions. So to protect the coated surface against possible stresses, mechanical or chemical, deterioration, physical or environmental. So we are using paints, of course, to protect, for example, mostly your roofings, okay, to protect that one against environmental deterioration, okay. Or if that surface is in contact with chemicals, then maybe we need to apply a certain type of paint which is chemical resistant to protect that certain surface. And then of course, other function of paint is aesthetics, okay, to decorate the structure by giving a smooth and color finish. And then of course, check penetration of water, okay, waterproofing, that could be used for waterproofing paints. There are these certain types of paint that contains a material that is an agent of waterproofing. So check the formation of bacteria and fungus which are unhygienic and give ugly looks to the wall. So this is also to protect, okay, the what we call this one, the looks of our surfaces. So the same purpose as your second here on aesthetics. And then check the corrosion of metal structures. So commonly on structures, let's say, on actual construction, if we are doing construction and suddenly we will stop the construction because maybe there is a short of budget, and then there are protruding bars on your construction, we need to apply what we call as the anti-rusting paints, okay, a certain type of paint that will make your metal anti-rust, or that will prevent from corrosion or from rusting. So that maybe even after a long period of time before we will continue the construction, then at least the protruding metals will be still protected against corrosion or rusting. So that maybe, let's say, we will continue that after years or months, then we can actually now remove the paints, okay, that we applied, and then that will still be a metal which is on its original shape or original state. And then check the decay of woodwork and to varnish the surface to display it better advantage. Okay, so also to prevent the wood materials, so we are applying paints. So these are the components of the paint. We have what we call as the base, the filler, the vehicle, the thinner, the dryer, the colored pigments. So actually the paint will contain this with different amounts, and then of course some of this might not be contained by this specific type of paint, depends on the purpose. Okay, so if you say base, you can read about that. Inner filler or extender, what is vehicle or binder, what is a solvent or thinner, dryer, coloring pigments. Okay, you can read about those. And then these are now the types. If we are using this paint on a wood wall, we should be using an enamel paint. Okay, you can read this one. These are the contents of that. And we have here the preparation, okay, or the purpose. So as you can see there, we should have here a primer, first coating or second coating, enamel gloss, okay, or gloss enamel. That is the type that we will be using. And then thinner will be a paint thinner. If you say thinner, that should be the one to be that will serve as our solvent. Okay, thinner. So that is for wood walls. Okay, and then for concrete or masonry surfaces, we will be needing a latex paint. And then these are, of course, you can read about that. We will be using here a primer, which is a flat latex. And then for a second coating or first coating will be a semi-gloss. So we will be using here a latex or gloss latex. And then the thinner here, or the solvent that we will be using for a latex pen, is water. Okay, so these are the difference. Okay, these are the difference on the paints. It depends on the purpose. Okay, for this type of enamel paint, for that to be in contact, or for that to what do you call this one? For that to stick on your wood wall, we need to be having this type of solvent. Okay, paint thinner. And for masonry, we need to have a thinner, which is water. So those are the difference of these different type of paints, which is to be applied on different surfaces. For metal surfaces, we will be using a type which is acrylic paint. Okay, so in this type of paint, our primer there, or if you say primer, by the way, what is the primer? Okay, there are stages of painting. We have what we call as the first coating, second coating, and even finishing. Okay, so the very first application, this is what we call the primer. Okay, the reason of the primer is for us to have a total connection between the final coating with the wall. So the first coating will serve as the binder of the final coating and the wall. Okay, so that should be followed. The primer should be followed, because if your primer is not what do you call this one, for the purpose of the surface of this specific surface, then that will actually give us defects on the finished paints. Okay, because your final coating will not connect totally with your surfaces. So again, your primer should be followed. And then we have here for acrylic, again, your primer here is red oxide, red lead or zinc chromate. And then second coating will be acrylic paints or roof paints. And then our thinner or our solvent there could be a lacquer or water. Okay, and then we have here what we call as the varnish. Okay, so of course you know what is a varnish. This is type of paint with a solvent that evaporates to leave a hard transparent glossy film. Okay, we call this one the varnish. So final coating, varnish. Thinner for that is coating thinner. So this varnish is actually commonly used on final coating, and then we are commonly using this one on woods, okay, to make your surface smooth and of course glossy. Varnish. Okay, so these are the paints, different types of paints to be applied on different surfaces. Okay, you can see it here. You can read about the description. Okay, and then of course the description of the components of your paints. And also we had here your ceramics. You can read about your ceramics. And then we have here, you can review about your steel here. And then of course your woods. Okay, you have here your woods. So that is for module 4. Wood, metals, paints, and then of course your ceramic products. So if you have a question, we will be discussing that on our live meeting. So thank you very much for watching.